Welcome back to AP Statistics with Mr. Walton. This morning, this afternoon, this evening, let's talk about inference for chi-square using the test for homogeneity or independence. For these two, let's keep in mind that we're talking about some slight differences. We want to keep track right here, what I'm going to highlight for you in yellow. For homogeneity, we are looking at and thinking of two different samples, possibly from two different populations, but at least two different samples that are independent from each other. We're thinking of them as saying, yes, different. Versus down here with our test of independence slash association, we're thinking of them from a single population. We're thinking that they're classified by two categorical variables, and therefore we're going to ask ourselves two different sets of hypotheses. First of all, if we're talking about homogeneity, we're right here. We're talking about the proportions being the same. And we're going to write that out in words and symbols. So what that means, if we have, the proportion of G equals the proportion of F equals the proportion of H equals the proportion of I, whatever those cases may be, we can use abbreviations, but we're going to show what they are. If they're not all equal to each other, we're going to write down the percentages. Now, let's also focus on the fact that since we're talking about two samples, we're talking about multiple SRSs, so we're talking about two different samples here. So we're not going to lose sight of that. And then we're going to come down and look at our test of independence. We're going to keep those same assumptions, except for here we're talking about one sample. All right, and then we're going to talk about, is our variable independent from our second variable, or are they not independent? Let's keep track of the fact that we're going to talk about no association matches independence versus association means they are not independent or they are dependent. Let's take another look in some colored notes. If we're talking about homogeneity versus independence, again, homogeneity, we're talking about independent SRS samples of some sort, random selection, random allocation. Independence, we're thinking of one sample, and we are categorizing within that one sample sets or classifications, and we're thinking of one population. For our calculations, expected counts, we definitely want to keep track of the fact that we're going to still calculate our chi-square test statistic. However, when we calculate our expected counts, we're going to do row total times column total over n, and our degrees of freedom are going to be rows minus 1 times columns minus 1, and we abbreviate that as r minus 1 times c minus 1. All right, knowing that we got this set, we're going to look at our example. All right, so as we read about our hikers, we're going to ask our question, does our data provide convincing evidence of an association? Okay. As soon as I see that, hopefully we're thinking, independence slash association. So we're not going to talk about homogeneity. We're going to talk about independence or association. We need to calculate our expected values. You'll see that I have them here. If you recall, we talk about the long formula being row total times column total divided by n. Well, they told us what our n was. They said n is equal to 200. All right, so then we would have to calculate our row totals, 20, 50, 50. So I have 120 here, which means I have 80 here. And then our column totals, I have 30, I have 80, and I have 90. And again, that gives us 200. So to calculate this 18, I would say, for this one right here, for my expected counts, I'm marking it right now, I would have 30 times 120 divided by 200. So I'm hoping that you guys can see that that gives us that 18. Awesome. So then we're going to talk about our hypotheses and writing them appropriately. And we have this. Our null hypothesis, direction is independent of experience level, versus our alternative that direction and experience level are not independent of each other. So looking at this, the first thing I want you to do is let's talk about and let's review, how do we do this on the calculator? So here it comes, popping up, boom. We first want to put our data into the matrix. So we're going to go second matrix. It's a 2 by 3. So we want to edit it. We want to hit enter. And we put our data in. You can see that my data is in, so you put yours in, we're good to go. We're going to quit. Then we're going to go to stat. We're going to go to tests. We're going to go to the chi-square test, which is C. Well, one more. Here we go. We're going to hit enter. It's going to say, hey, there's an observed matrix, there's an expected matrix. Do not touch the expected matrix. Leave it alone. It's going to calculate it for you. Just jump down here and say, yep, I've got matrix A. Boom. And there is our chi-square value, our p-value, and our degrees of freedom. So we're ready to rock and roll. Now, what I want you to notice also is if we leave here, go back to our matrices, it will give us our expected counts. In B, we hit enter and bam! Those are our expected counts. We're good to go, rocking and a-rolling. Nice! So, to recap, I have saved this for you. Dun dun dun. Screenshotted this. So we have our matrix A. We're going to go to our test. We're going to get our beautiful screen that looks like this. We're not going to touch the expected matrix. And then we're going to get our values. Yes. All right. So we're going to use that information. What comes after? What comes after our hypotheses? That's right, conditions. Try it now. All right, so hopefully you got your angry conditions. So randomness, it's given that they were randomly selected. Also, for independence, it is reasonable to assume there are more than 2,000 hikers in our entire population. So hikers should be independent of each other. Please don't forget to write that something is independent of something else. And lastly, for E, since all of our expected counts are greater than or equal to 5, we will continue to calculate a chi-square test of independence. You've got to tell me which test you're running. All right, so next up, we should put in our calculations. All right, we're scrolling down, calculation time. Try it, it's going to pop up in just a second. Here we go, calculations. Do we have our degrees of freedom? Do we have our formula for calculating our chi-square test statistic? Do we have our expected counts listed above? Yes, we did that. Do we have our beautiful curve? It is only skewed to the right. Only skewed to the right. And do we have our probability statement with our p-value? Yes, look at that p-value. Crazy, that's big. Last thing, what are we supposed to write about? We're supposed to write about the p-value in context. What does it mean? Okay, try it. Ready, go. Alright, so since our p-value is larger than any typical alpha level, we fail to reject our null hypothesis. Therefore, the evidence suggests that experience level and choice of direction are independent of each other. And we are done. Woo!